Thank you for joining us today in this online edition of Science Saturday 2020. We are at Valdosta State University celebrating National Chemistry Week. The printouts with information and the materials list of the activities shown are available in our photo album. Remember that to practice chemistry, we first have to practice safety. Follow Millie safety tips. Always work with an adult. Read and follow all directions. Read any warning labels on the materials used. Make sure to clean up once you're done and wash your hands after every activity. We hope you enjoy our online Science Saturday.
Hello! Here at Valdosta State University's Chemistry Department, we'd like to talk to you about National Chemistry Week. My name is Thomas Falkenhausen.
My name is Danielle McKay.
And the theme this year for National Chemistry Week is sticking with chemistry, where we're talking about the chemistry of sticky things. But it kind of begs the question, what are some sticky things?
Candy.
Oh yeah, and honey,
Yeah, and soap.
and glue.
Oh, let's make some glue.
Yeah, but first before we make some glue, we should talk about some safety precautions, right?
Yes.
So we put on our safety lab coats.
Put on your safety glasses
We have our closed-toed shoes on.
and tie up long hair.
Awesome. And I think we're ready. Now that we got our safety gear on, let's make that glue you were talking about earlier.
How are we going to do that?
Well, I guess we have to think first, like, what is glue?
I think glue is a polymer.
Oh yeah, polymers. There's the structures that are sort of like beaded necklaces where it's like a bunch of small molecules chained together. But what are some things that have polymers in it then?
No, right.
Milk! Oh, yeah, that's right. Milk has the proteins. But they're arranged in like special ways, right?
Yes, they're arranged in micelles that look like this.
So how do we go from the micelle to a long chain?
Well, you'll use something to break it apart.
Oh, like vinegar?
Yes.
Oh, okay. So right now we have our milk on the hot plate that's sort of stirring and it's warming up. But you're saying once I add the vinegar like this, it's gonna start sort of curdling, right?
Yes.
So then what do we do next?
Then we use something to separate the curds.
Oh, okay. That sounds great. So we added about 118 ml or a half a cup of milk. We let it sort of warm up first. And then we added about 15 mLs or a tablespoon of vinegar. And then now we're letting it sort of stir until it precipitates out all of the proteins that we were talking about.
Yes.
Sounds great.
Now that we have added the vinegar to our milk, we have formed curds. So I will turn off the heat, and we are now ready to filtrate the liquids from the solids. So I'm going to take a filter paper and a strainer, and you can use the same thing at home. And I'm going to pour this in here. Kind of shake the liquids out as much as you can. I'm going to grab another piece of filter paper in order to kind of squeeze the liquids out a little bit more. Now I'm ready to transfer the curds that formed into our beaker. next I'm going to add a little bit of water and some baking soda in order for the carbonate to react with the acid. And just a little bit, maybe like a teaspoon. And as you keep mixing, you can see that the curds that are kind of forming are turning into it will eventually turn into a sticky residue, which will be our glue that we made. So eventually, after mixing, this is the final result. And lastly, this is now what the curds are going to look like. So before it was a like more of a combined structure, and now they look more like spaghetti, like really mixed up together. And these stick together, like they more stick together now versus how they were before. So this is how they now look, the curds. So this is how we make glue from milk and vinegar. So join us next time for a discussion on reactions with this and how we can test that this actually works, and we can compare it also with commercial glue. Thank you for joining us.
Hi, my name is Shira Lagarde. I'm here with Valdosta State University, and this week we're celebrating chemistry because we stick with chemistry. Today we have peanut butter and honey, and what other sticky things do you have at home to measure stickiness? Scientists use different instruments to measure the stickiness within substances. We are going to be building our own sticky-o-meter. First, you're going to need to grab a parent or guardian because safety comes first, and then you're going to need cups of different sizes, string, pennies to measure it, tape, scissors, and let's get started with building our sticky-o-meter. And then you're going to need a ruler. So get your string and your small cups and your parent so they can stick some holes through the small cups. To stick a hole through the small cups, you can pinch the cup and cut it with your scissors. After which you're going to stick the string through the small holes and attach the string to the ruler. You can attach it with some tape after wrapping it around. The next step after that is you're going to grab your large size cups and a pencil and tape it to the cups. When you do that, it should balance out like so. The short one on the side, this is where you'll put your pennies, and then this one over here is where we're going to put our sticky stuff. After you have your sticky-o-meter assembled, you're going to get your plate and spread some peanut butter or any sticky substance on the plate. And then just apply a little pressure to have the cup stick to the plate. Then, next, we will get something to measure to put into the cup. You can use pennies, quarters, marbles, sand, water, anything you can measure afterwards. And how many pennies do you think it's going to take for this cup to take up? 5, 10, 20, 50? Well, let's see. 5, 10, 15, 20, 25, 30, and it took 30. You can repeat this experiment with other sticky substances that you have at home, such as honey, ketchup, mayonnaise, and after repeating it, just compare how many pennies it took to make it not stick. Whatever takes more pennies, it sticks more. If you enjoyed this experiment and would like to try more, you can go to the American Chemical Society and the Celebrating Chemistry Journal and find more because you enjoy sticking with chemistry.
Hi, my name is Kushbu Patel and I'm a student at Valdosta State University's Chemistry Department. And today we are going to be celebrating National Chemistry Week and our theme is Sticking with Chemistry. But do you know why things stick? Okay, to determine how things stick together is similar to the magnetic fields of these magnets. Similar forces like these, like a negative and a positive force, they stick together, but if we do negative to negative or positive to positive, it repels to one another, just like these magnets. Okay, similar to these magnets and their forces, these gummy bears are also sticky due to the attractive forces from the particles that make them. Just like the gummies, these marshmallows work the same way. Did you know that these substances are made up of small, tiny particles? These are called molecules. Molecules are so tiny that you cannot see them with the naked eye, which is why we have to build models, such as this water model. And this is a glucose model, which is a lot bigger and a lot complex. And now we are going to make a water molecule. So first I'm going to take an oxygen and connect it with two hydrogens right here. Okay, so this is the oxygen and these two are the hydrogens, and this causes the bent shape. And now to make one at home, we are going to take a red gummy bear and put two toothpicks at the very ends, and be sure that you don't poke yourself with it, and connect two marshmallows together just like this, causing a bent shape. And now to further explain, I'm going to take other water molecules that are already built and connect them together like this. So the hydrogens will go to the oxygen, and you just keep doing that. And this will create a bigger model like this. We can see that they are sticking to one another when the water goes from one cup to another by its flow. And now you can build and create your own models using toothpicks and marshmallows and gummy bears, and have fun sticking with chemistry. Thank you.
So we're celebrating National Chemistry Week, and students are making models of some molecules. So what do you have?
I have ethane linear.
Excellent. And what do you have?
I have ammonia and it's trigonal pyramidal.
Excellent.
I have
Thank you.
methane tetrahedral.
All right. And
I have glucose and the carbons are tetrahedral.
thank you. And we're also studying clusters of water molecules to see how they dissolve different substances. Hello. Today we're celebrating National Chemistry Week at Valdosta State University. My name is Linda de la Garza and I am a professor of chemistry. And I want to show you today some reactions. If you are at school, your teacher may have the Kids and Chemistry kit. But if you're at home, you can still observe reactions using these common chemicals. You are going to need magnesium sulfate, which is Epsom salt, sodium bicarbonate, which is baking soda, sodium chloride, table salt, and calcium carbonate, a dietary supplement. We also are going to need an acid. We have here citric acid, but you could also use vinegar. Citric acid is found in the materials used to make jams and preserved fruits. You're also going to need some water because we're going to prepare a solution of the acid. And at home, if you don't have the balloons to trap the gas formed by these reactions, we can actually use soap. The soap solution will help trap the gas form. Why do we want to make these reactions? Because there are some cool toys that you can actually find at the store, these self-inflating balloons. They contain chemicals that when reacting will produce a gas and will help inflate the balloon. Let's try it. I can hear the fizzing, so I know something is happening. And little by little, the gas form is inflating the balloon. Look at our balloon, it's all inflated. So let's try our reactions and see which of these chemicals will help produce a gas so that then we can use it and have fun. So the first thing we're going to do is prepare a solution of the citric acid. Or again, you can just use vinegar from home, has this solution. So to prepare it, we're going to put about a cup of water with 2 spoons of the citric acid. Okay. And I already added some, so I'm not going to add more, but we'll just put 2 scoops in there and then shake it to dissolve and prepare the solution of the acid. Once we have this solution, we're going to measure portions of it. You can use one of those medicine cups or even just spoons, or just make sure that you have about the same level of the liquid on your containers. And I'm going to go ahead and pour some of these also on the cups that you will use for when you're at home. Again, we just want to have about the same amount. Here I put close to 10 milliliters. And I'm leaving one that is our control, doesn't have any chemical, and the rest has the chemicals that I mentioned before. So let me show you. I'm going to add the liquid to the last one. So again, this is our acid that is going to react with our solids. Now we're going to grab our balloons and put the solid in the balloon. So here I'm going to show you, I have a funnel attached to the balloon and I'm going to add one of the substances. This one is calcium carbonate, and 1 spoon is enough for this. And we're just going to shake it so everything goes inside of the balloon. And then we are going to attach it to its test tube. So where is my calcium carbonate? Is the last one. Right there. And then I have the sodium chloride. And the bicarbonate. And the Epsom salt or magnesium sulfate. And the last one is my control, so that one, the balloon is empty, doesn't have any solids. In order to make comparisons, we always have to have a control. So again, the liquid contains the acid, the citric acid, and now I'm going to put my solids here again. Magnesium bicarbonate, sodium chloride, and calcium carbonate. And now we're ready to start our reactions. So we're going to just flip the balloon, so or the solid goes into the solution. Shake it a little bit. C1 is reacting quite fast. Oops, the last one still had some powder that needed to go down. And while that's reacting, I'm going to show you what you can do at home if you don't have the test tubes. Remember, I put the acid solution on the cups, about the same amount, and you can have the 4 or 5 cups with your control. And we're going to add some soap. The soap is going to make the function of trapping those gases if anything is formed. So we just dissolve the soap first, just swirling, and now we can add our reactions. So I'm going to add the magnesium sulfate here, first one spoon, and swirl, and then I'm going to add the bicarbonate on the other one, 1 spoon, and let's swirl. I'm going to show my test tubes too. So this one is really reacting. You can see gas getting trapped by the balloon. This one is not really doing much. This is our sodium chloride. And this last one is the calcium carbonate. Let's make sure that solid goes into the solution. So a couple of these substances actually are giving us a reaction. They're making that gas and inflating the balloons, where the other ones are not really doing much. So let's look at these from the molecular view using models. So let's look at some models for these reactions. The first one that actually made bubbles is the one that we tried here with sodium bicarbonate, but I'm going to show you the model with the calcium carbonate. So for calcium carbonate, we have calcium has the blue chip, carbon has the black chip, and then the oxygens has the red chips. Then instead of using citric acid or vinegar, because the molecules are bigger, I'm going to show you the reaction with hydrochloric acid, HCl. So it has a hydrogen, which is the white chip, and the chloride, which is the blue chip, the green chip. So now we are going to actually mix them and combine them. And what we see is that the calcium forms calcium chloride, and the carbon forms the carbon dioxide, which is the gas that fizzes, and then water. And water is H2O, so water with the 2 hydrogens. So as you can see, because we started with the compound that had carbonating structure, we are able to form then the carbon dioxide gas that fills our bubbles, fills the balloons in here. And if we want to write the reaction, we will write something like this: the calcium carbonate reacting with hydrochloric acid to form calcium chloride, water, and our carbon dioxide gas. Now, in contrast, let's check what happens if we react the acid with the sodium chloride. Here I have the model, sodium in purple and chloride in green. And again, I'm reacting it with an acid, hydrochloric acid, HCl, hydrogen in white, and chloride in green. If we mix those, you can see that sodium will bind the chloride, and the chloride will bind the hydrogen, and we're back to where we started. There is no reaction here. We can see it with our symbols, sodium chloride reacting with hydrochloric acid, just giving us sodium chloride and hydrochloric acid again. So that's a no reaction, and we see that nothing happened in this test tube. So that's all I have to show you today. Thank you for joining us, and keep celebrating National Chemistry Weeks with us at Valdosta State. Have fun. Once again, thank you for joining us as we celebrate National Chemistry Week 2020, sticking with chemistry with this online edition of the Valdosta State University Science Saturday. Printouts with information and materials lists for the activities shown are available in our album.